Okay, we are looking at lesson 6 for chapter 8, solving linear equations. We are continuing on with the same kind of work that we have been doing through lessons 1 through 5, I guess. The differences in this lesson is we're going to have variables on both sides of the equal sign. So we are going to need to group any like terms before we start solving for our variable. So in previous lessons, we've had constants that need to be grouped together. Now we're going to have variables that need to get grouped together. So just a reminder that we need to group like terms. If you need a visual reminder, maybe you want to sketch out what the x's versus the constants look like, or grab a pack of tiles when you come in class. But think of grouping like terms. Okay? So again, when we group like terms, we separate our expressions into our different terms. So that way the sign always goes with the term that's behind it. So looking at the first example, I have 0.5x and plus 0.25x on the other side. I need to group them together. Whether I move them to the right or the left side of the equation doesn't matter, but I always try to move to the side so that the x will stay positive. It's not a big deal if it doesn't. That's just sort of my preference. So in order to do that, I'm going to move the 0.25x to the other side of the equation. The way we do that is by canceling it out. So it's going to cancel it on that side, on the right side. Whatever we do to one side of the equation, we do the same to the other. So we get left with 0.25x equals 1.6. Those cancel out. Okay? So now I'm thinking I only have one x. I need to solve for x. It's being multiplied by 0.25. I'm going to do the opposite. I'm going to divide by 0.25. So x equals 6.4. And then if I wanted to, I could check my equation. This time, if I'm checking, I'm not just substituting once. I'm going to have to substitute twice. So if I'm going to check, I'm going to go 0.5x equals 1.6 plus 0.25x. 0.5 times 6.4 should be the same as 1.6 plus 0.25 times 6.4. Slide this up a little bit more. And so then we get 3.2 is equal to 3.2. So we get 3.2 on both sides. So I multiplied and then added. Just do it all in one step. It's fine. We want to get the same on both, so our checking works. X is 6.4. Our solution is correct. Okay, looking at letter B. So I have 7.52 plus 3.28. So I have two groups of A, one on each side of the equation. I can move them either way, it doesn't matter. I'm going to move them, because the A is by itself on the right, let's move it to the right. Again, it doesn't matter which way we go. So minus 3.2A minus 3.2A, so 7.52 plus 0 equals negative 9.4. Okay, so now looking how is the 9.4 connected to the A? Well, negative 9.4 is being multiplied by A. So the opposite of multiply is divide. So we're going to divide both sides by negative 9.4. And we get a solution of negative 0.8. Right? Positive divided by a negative gives us a negative. Negative divided by negative cancels out to positive 1. So A is negative 0.8. Again, if I'm going to check, I need to substitute on both sides. So 7.52 plus 3.2 times negative 0.8 has to equal negative 6.2 times negative 0.8. Oh, running out of room. Okay, 0.8. And so when we multiply, following bed maths, we're going to multiply, and then we're going to add, and I get 4.96 equals 4.96. So we're good. Same on both sides. So negative 0.8 is the correct solution for A. Okay, so I'm going to do C for you, and then I'm going to get you guys to try the other ones on your own. So for letter C, we have fractions. So first thing we usually try is to put them into decimals. 1/3, however, is not a decimal that we can work with because it's repeating, so we need to leave it in fraction form. I can, however, multiply by something to get rid of the fraction. So I'm going to multiply the entire equation by 6. Because if I count by 3s, I get to 6. If I count by 2s, I get to 6. If I count by 1s, I get to 6. So I end up with 6 over 3y minus 6 over 2 is equal to 6 over 6y. 6 divided by 3 gives me 2y minus 3 equals 1y. Okay? I'm going to move the y's so that they're on the same side now. I notice that there's variables on both sides of the equation, so I'm going to group like terms. So I'm going to minus a y and then minus a y. So we get 1y minus 3 equals, well, there's nothing left, so 0. Get rid of the constant by adding 3. So y equals positive 3. Okay, and then we could check our solution as well. I'm not going to check these ones. Letter D, you're going to do this one on your own. And I'm going to get you to do E on your own, but I'll show you how to do F, because F is a little bit, might seem a little bit trickier. Okay, so for F, a couple things we could do. We could try dividing both sides by the denominator, or we could use distributive property and go 2x over 2 minus 1/2 equals 2x over 3 plus 1 over 3. But then we're having to add and subtract with fractions. So let's get rid of the denominator. And so I'm going to multiply everything by a multiple of 2 and 3. So 2 times 3 is 6, so I'm going to use 6. So on the left, we get 6 times 2x minus 1 divided by 2. And on the right, we get 6 times 2x plus 1 over 3. Notice that I'm putting everything, the expression on the top of each fraction in brackets. So that way we know each term gets multiplied by 6 and not just one of the terms. So 6 divided by 2, this leaves me with 3. So we get 3 times 2x minus 1. 6 divided by 3 leaves me with a 2. So then 2 times 2x plus 1. So now from this point, I can either use distributive property, I can divide. However, if I divide again, I'm back where I started. So I'm going to distribute, or rainbow. So we get 6x minus 3 is equal to 4x plus 2. I notice that I have 2 terms on each side of the equation that I need to combine. If I move all the x's to the left, they will stay positive because I have more positive. If I move them to the right, they become negative x. So I'm going to move them to the left by going minus 4x. So then we get 2x minus 3 equals 0x plus 2. And now this should look really familiar for you. Add 3 to both sides. 2x equals 5. Okay, so that's where we're at. So I'm going to check D and E from you guys tomorrow. Okay. These last questions look really tricky at first, but they're not so bad when you see them. The reason why I put the graphs on here is not that you are actually going to graph them, but I want to show you what they look like. So it says, what value of x makes these two equations equal? So when we say they're equal, that we mean that one will equal the other. So when this equation is equal to this equation. So we're going to, instead of leaving them as 2 separate equations, we're going to put them equal to each other because we want to know when are they equal. Okay. Excuse me. So we're going to solve the same way as normal. So I notice each side has 2 terms again. I'm going to move the negative 6.1x because if I add it to both sides, then x becomes positive. If I was to move the negative 3.2 over, the x would become more negative, and then I'd have to divide by a negative, and then I'd have to remember sign rules, and who has time for that? So I'm going to add 6.1x to both sides. So then we get left with 4.9 equals to 2.9x. So now it's positive, minus 3.8. So now again, we only have one x, but we need to isolate it. So we're going to add 3.8, get rid of the constant. So then we get 8.7 is equal to 2.9x. Divide both sides by 2.9. We get x is equal to 3. So that means when I go to my graph, if I go to x of 3, that's where they're going to cross, somewhere along that line, x equals 3. That's where they're equal. Now, and this is a bit of an extension, if I wanted to know the exact point where they crossed, I'm going to find out what the y coordinate is. And I could use either equation. I could either use y equals 4.9 minus 6.1x, or I could use y equals negative 3.2x minus 3.8. So I'm going to substitute this x value into the equations. So now that I've substituted in, I'm following that math, and I get negative 13.4. Doesn't matter which one I use. So that means the point where they cross is going to be when x is 3 and y is negative 13.4. So they should cross somewhere around here, because negative, it's going to be, I'm ishing it, right? It's close. So now, by the power of Smartboard, so here's the, oops. Okay, so there's the first equation graphed. It's in the bluish purpley line. So notice that it kind of goes through that point negative 3, positive 3, negative 13.4. And then when I take the second line, whoops, and connect it, see now it's the red line. So notice how that's where they cross. So that's where the two lines are equal to each other. So if you are someone who's working to do some extension work, this is actually where we can start investigating other ways of finding where these two lines cross and where they are equal to each other. That's kind of a grade 10 skill, but those of you that are ready to start working at it, we can do that kind of after this lesson. We can start looking at that. So again, I'm going to ask you to solve these two by yourself, remembering that we put one equation equal to the other, so the y's are gone, and we have 2x minus 1 is going to be equal to 2x plus 1. So I want you to figure out at least the x coordinate, but maybe even the y coordinate as well. Okay, so find where they're going to cross on the graph, and I'm just going to, I'll do this for you, so you get, this is my hint for you. So that's what it's going to look like. So that's kind of the general area that they should be crossing, so hopefully that's a good hint for you. So I'm going to check this and letters D and E in class for you tomorrow. Please have them done.